Hello, Algebra 2 students. First of 3 videos to go through some practice questions that the state makes available. We're going to do 1 through 13 in this video, and then we'll do the next set of 12, and then the next set of 12. There's 37 total. Okay, let's get started. Before this gets too long, we're going to listen to lullaby versions of Beatles songs. I totally forgot I bought these when my kid was born, and it's kind of fabulous. Very calming. Hope it doesn't put you to sleep. Don't think I put you to sleep. I hope not, but okay. First question. Radical equation. Remember, with a radical equation, we have to isolate the radical part. So let's do that by subtracting 6. So 3 root 2x minus 4 is going to equal negative 3. Divide both sides by 3. I'm already seeing a problem. Does anyone else see a problem? Because I see a problem, and if you don't, it's okay, because I'm going to keep going. If you do, I'm so glad you're clued into it. We got to get rid of our radical, so we're going to square both sides. And if you're not clued into what the problem is, don't stress about it, because you're going to see it in a minute. Square the radical, we get the radicand. That's the insides without the radical sign. Square a negative 1, you get a positive 1. Add 5 to each side, 2x equals, add 4 to each side, 2x equals 5. Divide by 2, x equals 5 halves. All right, but don't just go circling. Double check. 5 halves times 2 minus 4 and then plus 6. So 5 halves is going to be, what is that? So that's going to cancel. It's going to be 5, so it's going to be square root of 1, or just 1, plus 6. Does that equal 3? Does 9 equal 3? No, it does not. So that doesn't work. So you're going to get the empty set or the null set, also signified with that. Okay? Right, always remember to check. What kind of equations do we check? Radical equations like this one, and the other one is absolute value equations. Okay, other polynomial equations, you should be all set with what you find. Alrighty, here we have a system of equations. I know this is totally your favorite subject. That's sarcasm, so calm down before you jump all over me. Let's notice a few things about these. Let's see, x squared but no y squared, so this is a parabola. Only 1 squared means a parabola. X and y linear. Okay, so we got a parabola and a line, so your possibilities are none, no solutions, 1 solution, and 2 solutions. Just thinking about the shape. Parabola, line, or parabola line, or a parabola line. Either one of those 3. Excuse me. So I'm going to take the second equation and solve it for y, giving me negative x minus 20, and that's what I'm going to plug in for y. I'm going to have a quadratic equation either way, because if I plug in the, if I solve for x and plug it in, I'm going to have to square it anyway in the other equation. So this is probably the easier, the path of least resistance. All right. X squared plus 6x minus 3x plus 60 plus 6 equals 0. X squared plus 3x plus 66 equals 0. Is that right? Doesn't seem right. Well, let me think about it. Hold on. I figured out why it didn't seem right. Because it was wrong. So negative 60 is what the mistake there that I made. So this is x plus 9 minus 6. So my solutions for x are x equals 6 and x equals negative 9. So those are my 2 solutions for x. I'm going to plug both those in to the linear equation, remember, and go ahead and find a value for y. Let's see, that's 11. So y equals negative 11. And we know our answer is C already, but we'll do the other one anyway. 6 plus y plus 20 equals 0. So 26, so negative 26. Yep, that's it. Not too bad. It almost always turns into a quadratic, guys. Next. Which function is represented by this graph? So we've got something that is clearly a rational function. A rational function has the variable in the denominator, and it gets you this shape. And what it is, guys, actually, and you'll do this in algebra, in pre-cal, is it's a hyperbola rotated. Hyperbola rotated. Hyperbola is the one that normally gives you this kind of graph. with both sides. We looked at this just a little tiny bit, not a ton, because you don't learn conic sections here, but you can actually rotate that using trigonometry, and that's how you get something like that. Excuse me. Okay, or that's one of the ways you can get something like that. So we've got some asymptotes. Let's identify our asymptotes. Looks like one of them is right here. All right, which is the asymptote x equals 3. So x equals 3 is an asymptote, so x minus 3 is going to be a denominator. So, can't be this one, can't be this one. My other situation here is I've got a y-intercept that appears to be 0. If that's the case, then my answer is probably this one. If we were talking about this bottom one down here, the horizontal asymptote would be x equals 1, because it's the ratio of the coefficients of x. So 1 over 1, 1. Here, it's also the ratio of the coefficients of x. Hey, let's think about it that way. Check it out, guys. And that's 0. 0 over 1, 0. So that works out well. Next one. Graph of g of x equals x plus 1 over x has 2 x-intercepts and no y-intercept, 2 x-intercepts and 1 y. So this is definitely a graphing question. Now, I should think about this while I'm actually working and not do these questions before I get to them, but I am going to go ahead and break out my graphing calculator. Hopefully you have yours handy as well. And if you don't, keep in mind that there are quite a few free graphing calculator apps if you have a device that you can use, that you can find online. So x plus 1 over x. I apologize if I have my phone too close with the speaker. Let's view the graph. All right, and you know, the great thing about graphing calculator apps is it's really easy to zoom. Okay, so zooming isn't helping me, so I can't really even cheat, you know, with something that I would have on my, that I wouldn't have on my TI. Anyway, so this has a horizontal asymptote of x equals 1. So it's definitely going to cross here somewhere. So there's definitely going to be an x-intercept. This side is not, because it's going to be like this. Okay? So one x-intercept is most likely. So it's not these two. No y-intercept or one y-intercept, it's definitely no y-intercept, because a y-intercept is where x equals 0, right? Well, x is never going to equal 0. Definitely no y-intercept, so it's got to be C. So a little bit of a combination of graphing calculator and concept knowledge. Okay, another question about, this one's about end behavior, but another question about graphing a rational equation. So we're going to think about this two ways. Actually, we're going to think about this algebraically, and we're going to think about it graphically. Which of the following describes the end behavior of this function as x approaches negative infinity? So we are talking on this graph about what happens as you go really, really far in that direction. Well, first of all, what does the graph look like? Well, the graph looks like this. And of course, you get a graphing calculator when you're taking the test. You know, anything you do in my classroom involves graphing like this. You do have the calculator to give yourself a visual. Now let's talk about the asymptotes algebraically as well. You've got definitely a vertical asymptote of 0, because x definitely can't be 0 in that denominator. Then you have bigger degree on the top than the bottom, goose egg. Okay, 0, goose egg. Apparently I never said it was an egg, you guys said in class, but whatever, I think I did. So y equals 0 is another asymptote. So it's kind of a weird looking graph, first of all. And second of all, we can definitely see here that the red curve is approaching, getting closer and closer to 0 for y. So that's going to be our answer. Now let's think about it also conceptually, a little bit algebraically, mostly conceptually. Now this isn't really mathematically accurate, so don't quote me on this. But as we get closer to negative infinity for x, this is going really, really closer to negative infinity. And the bottom is going closer to a much greater value than that, because as you get the bigger your number, the bigger the square. So this is going to approach 0 because you have a so much bigger number on the bottom than the top. So as the bottom gets larger and larger and larger, and the top gets, it's also large, but it's not nearly as large as the bottom, it's approaching that So it's like infinitor, which those of you who've read John Green know what I'm talking about when I say that, which is super depressing. So larger negative infinity or more negative infinity. Anyway, you understand what's going on. I could have just stopped with the graph, but moving on. Excuse me. The amount of tax lost revenue from tickets not sold for a concert is shown in the table. The ticket prices include tax. So this one was on those practice items that you guys worked on in class as well. Remember to look carefully at which one's X, which one's Y. And in this situation, when you go ahead and you view the scatter plot, if you go ahead and view the scatter plot and then graph these 1, 2, 3, 4 at a time, you will find the correct answer that way. And the one that fits is the first one. Excuse me, what did I just say? Why would I say that? It's the second one. Burnout, what are you going to do? I'm exhausted. So not at all difficult. Zoom 9 to view the scatter plot. Turn the stat plot on. Turn the stat plot on. And zoom 9 to view the scatter plot, and then graph them. The second one matches almost perfectly. Next. Alrighty. I actually am re-recording this one because it got really messy, so we're going to start fresh with it. So this is a normal distribution question. Normally distributed set of 968 values has a mean of 108. Let's write that down. A mean of 108. Standard deviation of 11. Standard deviation of 11. Which is the closest to the number of values expected to be above 125? So 125 is our X that we're using. So our z-score formula is x minus mu over 1 over sigma. I was about to say 180. That doesn't make any sense. So we are going to plug in our x, which is 125, minus mu, which is 108, over sigma, which is 11, 17 over 11, which comes out to 1.54545, so 1.55. And then we're going to use our standard normal probabilities, our z-score table. So you're going to find your z-score. Remember, you look for the 1.0 and then the 0.05. The 1.5 and the 0.05, sorry. And you're going to find the number, when you go look for that, 0.9394. Now remember what that is. That is from here down. Shade, 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 shade. They're asking up here, how many would be above 125? So you're going to take that 0.9394, come up here. We're going to subtract that from 100%, or 1. 0.9394. Oh, one more zero above. 0 point. Okay. Subtract that, and you're going to get 0.0606. So in other words, 6%. If you want 6% of 968, when you multiply that, that's going to be 58.9 something, so 59. It might not be a 9 right here. I can't remember. 59. All right, next question. Okay, click and drag each selected property to the correct box. So this is a question where they're asking us to identify which property we're using over here. Okay, so I'm seeing in this one, let's see, right here, they have multiplied through that 4, and that is our double rainbow property, which is our distributive property. So that's this one. It goes here. Okay. Then I noticed that they have taken our 5i and our 12i and swapped them. And that's our commutative property. And now we've got some grouping action going on right here, grouped together. That is our associative property. And then they went ahead and substituted 17 for 5 plus 12. That's not hard. You know, I hopefully the properties are solid in your mind. If not, that's what you're going to review. Next question. Following sequence is given in recursive form. If A1 equals 8, find A3. All right. We need A1, we need A2 to find A3, so we're going to have to go in order. A1, A2, A3. A1 is 8. AN, for the second term, A2, is going to be 2 times A sub 2 minus 1, which is A1, and then plus 5. So 2 times A1, which is 8, plus 5. 16 plus 5 is 21. 16 plus 5, 21. We're going to do the same thing here. 2 times a3 minus 1, which is a2. So 2 times 21 plus 5. That's the definition of recursive. Remember, you need the previous term to get the next term. 47 is the answer we came up with. Alrighty, so we have, it's a slide I have to re-record because I messed up. So we have here, click to choose each function you want to select. You must select all correct functions. So that implies there's more than one answer here, but it could be one and it could be more than one. More than likely, it's going to be more than one. And I've found so far that most of them have 2 correct answers. Obviously, you can't use that as a hard and fast rule, but, you know, whatevs. All right. So which has the same range as that function right there? So if I graph this function, I have an absolute value graph, so it's V-shape, and it goes down to where -4 is. So the range here is y is greater than or equal to -4. This parabola also has the same range because it has a vertex at -1, -4, which I can find by putting into vertex form. Good chance to show that again. We're going to complete the square. And you got -3, and you got to even it out with a -1. So this is x plus 1, the quantity squared. And this is -4. And that gives you vertex form. So the vertex is -1, -4. This is going to bother me if I don't fix it. Right. There we go. So definitely vertex at -4. The next one's cubic. That means it's going to do this. So it's clearly going to have all real numbers as a range, so it's not going to work. This next one right here, if you go ahead and graph it and you look at your table, it definitely goes below -4, that -4 mark, because there are points of -4.5 and so on. Because the asymptote for this one is y cannot equal -5, because you'll never get a 0 and then -5. So this one, not going to work. This one is exactly like the absolute value one, except it's a radical function. So it looks like this, and it definitely starts at -4. So that's another one. So we have those 2, and then this one is a horizontal shift, not a vertical shift. So that's not going to work either. All right, no problems there. Okay, to indicate the intervals where this graph is only increasing throughout the interval. And we saw one like this on one of our practice problems in class. So I'm going to graph it. 2x to the third minus 3x to the second minus 12x plus 20. I'm going to hit graph, and it's going to graph. And, you know, the thing about questions like this is they kind of give us where to look right here. They're giving us where to look right here. So, from -infinity to infinity. Well, clearly the graph does something along these lines. So it's not increasing the entire time. No. Because there is a portion where the graph is decreasing. Right here. Decreasing. Going downhill. Like negative slope. So from -infinity to -1, that looks to me clearly like that's one of the intervals where it's going to be increasing. Okay, only increasing. I'm going to zoom out one time and see if it helps a little bit with the viewing of the graph. Yeah, I agree with this. Now, -2.5 to positive infinity. Well, again, I need to view my graph. It looks like it touches, this point looks like it's on the x-axis at 2. I can use second calc to find a relative minimum with my calculator, where I use that left bound, right bound. Excuse me. And we definitely get 2 for that x value. So that is at 2. So that's not going to be it right there. From -1 to 2, it is indeed going downhill. So that is definitely not it. And from 0 up to infinity, that is not the case because that's not a 0. It's the x of 2 to infinity. It's increasing on. So that wasn't too bad at all, but notice I did use a couple of things besides just my eyes in the graph. Home stretch now, only 2 more. Asymptotes. I think it's based on what we've seen in terms of practice questions and stuff, it's really likely that this is the kind of stuff we're going to see on the SOL. So let's start with our vertical asymptote. That's what x cannot equal. That's what x cannot equal. And then what in this case can x not equal? Well, it's 3. So that's your vertical asymptote right there. Horizontal asymptote, degree on the top and the bottom is the same. Write the variable terms in a ratio. Remember what the point is here? We're getting really, really big for x, or really, really small. So the absolute value of x is getting really, 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 really big. The top is 4 times bigger than the bottom. So that's the asymptote. Okay, y equals 4. So this one goes here. Last question for the first video. Okay, this is our last question for the first video. Permutation / combination. We don't know yet. We haven't read it. Type in our answer in the box. Store owner employs a total of 3 cashiers and 7 clerks. So 3 cashiers, I-E-R-S, and 7 clerks. Clerks. It's one of my favorite movies of all time, actually. The owner plans to select a committee of 1 cashier and 2 clerks. What's the number of different committees the owner could choose? Well, if it's a committee, it's just a group of people, the order does not matter. So the 1 cashier part, we know whatever we find in terms of the clerks, we're going to be multiplying by 3. Because you can only pick 1 cashier 3 ways because there's only 3 cashiers. But for this, where you're picking 2 clerks out of a group of 7 for a committee, it's definitely a combination. It's definitely a combination. And our formula for a combination is, let's see, can I do this from memory? Probably not. I'm not that good at doing this kind of thing from memory. Of course, I could use my calculator, but I don't remember where to find that stuff. Anyway, it's going to be n factorial over r factorial n minus r factorial. That's right, because the r factorial takes care, this is the part that takes care of the duplicates right here. So 7 factorial over 2 factorial times 7 minus 2 factorial. Lots of factorials. So 7 times 6 times 5 factorial. This is 5 factorial, so they cancel. And this is a 2, and that's going to make 3. So this is 21. So 3 times 21 is how we find our answer. 63 is our answer. Gosh, this was messy. All right, I'm going to call it quits before this becomes a 40-minute video. See you guys in class.